welcome everyone to this week's IPLD sync meeting. It's March 13th, 2023, and as every 2 weeks we talk about IPLD stuff and discuss what we've worked on, but also discuss any agenda items you might have, or also if you have questions, feel free to join. And also, please, everyone, add yourself to the hackpad. This week I also have an update because last week, or the past 2 weeks, I did an update on the Serde IPLD DAG CBOR, which is kind of Rust DAG CBOR implementation, a new release. Not many new things, but the important part is that it now has stricter decoding. So if you have CBOR data and it has null in it, it will error. No, if it has undefined, sorry, I got this wrong. Null is okay, undefined is not. And then also if you have indefinite sized elements, because in CBOR there's support that you have like a unlimited size list and you have just some stop operator. This is not supported in CBOR because what we really want is only one way of representing things, and for lists it would be 2 different ways. And the idea here was also that to first of all match the other implementations in JavaScript and Go, but also to be really like, I would rather be, because it's kind of like a new library, it's being strict in the beginning, and then if it turns out to be a problem with existing data or something, we can always add a feature flag or an option or whatever. But being strict at first is a good idea, I think, and then we can go from there. So that was fixed, and hopefully the library the Falcon virtual machine is using, and hopefully they will update it for the next release. I guess they will, because I've told the developers it shouldn't break anything what they're doing. All right, then next on my list is already Rod.
Yeah,
all right, I am busily typing up my updates.
Sean, you were saying something?
Yeah, I just put in the chat about there's a library in Rust that is deterministic CBOR. And I haven't really dived into too much detail.
You are, by the way, quite hard to hear. So if you can bump your volume a bit, it would be nice. But yeah.
Here we go. Try that.
Oh, yeah. Oh, that's way better.
Okay. I had just put something in the chat about deterministic CBOR that's coming out from Christopher Allen and Wolf McNally. I'm not sure the overlap between DAG's CBOR but they have actually an IETF application right now for deterministic CBOR, used in blockchain, mostly Bitcoin. Have a read. Yeah, and actually going at the RFC 8949, which is, I think, what you guys did too with the deterministic or canonical section. So I'm not sure how it's different, but worth a read.
Thanks. Yeah, I think the most important part will be like, what do they do with the ordering of keys? That's the that might be the catch. I will have a look.
Yeah, that's probably going to be the main thing. If I think that's the thing. If anyone starts down this path of deterministic CBOR, you have to decide first of all which things you want to exclude, and we exclude things based on our data model. So there's a bunch of stuff we don't bother including because it doesn't really work for our data model. But you could actually choose to include a lot more. And the other thing is map ordering, map key ordering. Yeah, that's interesting. Thanks for the link. Okay, my notes. So I've been doing a bunch of stuff around selectors and UnixFS. So a lot of the work I'm doing right now is focused on retrievals. So we've got a retrieval client for IPFS and Filecoin, which the ideal for IPFS and Filecoin is that they become the same thing, essentially. When you fetch from IPFS that you could also be fetching from Filecoin. And the whole point of Filecoin was that it was meant to serve as an incentivized storage layer for IPFS. So over time, we should see those things merging and becoming fairly transparent. Fairly opaque, really, in terms of where your data is coming from. So we have this retrieval client that we've been building out called Lassie, and it can fetch from Filecoin or IPFS. It's not like Kubo or another IPFS client in that it doesn't maintain a long-running connection or even long-running knowledge about the DHT. It doesn't bother doing DHT searching. It uses the index service, which now can do DHT searching for peers that have blocks. So we have these multiple endpoints that we can talk to discover who has what content. So Lassie is a really dumb client that doesn't maintain state. It's just for downloading content, and it can do from Kubo peers or Elastic IPFS or Filecoin storage providers. Anyway, right now our main use case is we're focusing on UnixFS because that's the main type of data people use. And Lassie is very IPLD prime centric. It's the way it uses the IPLD prime model. So we use selectors and we use all of the good pieces in like Go UnixFS node, which is an ADL for UnixFS. So there's been lots of fun sort of building out that little ecosystem of pieces that are not fully complete. Like there's some rough edges on some of them, but we're improving them. So last few weeks, the things I've been touching are there've been some changes to Go UnixFS node and Go car in parallel. So Go car is our primary utility for interacting with car files. If you're doing anything with car files, then Go car has a command line program that you can use to interact with cars, and it's mainly a kitchen sink that we throw utilities into. It does a whole bunch of stuff. Over time, I think it's starting to become a little bit more coherent. But one of the main tools in there is car extract, where you can extract UnixFS content out of a car. And to date, it has been focused on complete DAGs. So it assumes you have a complete UnixFS DAG and you're going to extract it. So you've done a car create, so you've imported a directory structure or a file, and car extract will do the reverse. But when we're doing retrievals, we're often dealing with partial DAGs and even very specific, just like one file in a DAG, because now with Lassie, we support pathing. So we can do really complex pathing from a root down through, a sharded UnixFS directory. The example actually, and it's become a test case, is to fetch a Wikipedia page from a Wikipedia DAG, which otherwise would be 170 terabytes, but just to fetch 6 blocks to get to a single page through the shard in the UnixFS. So you get a car with 6 blocks in it, and you want to extract that page. So the car is verifiable. It's got all the blocks from the root to the page, but you want to extract the page. So car extract now can do partial extractions. It can do path extractions as well. So you can say, here's my car. I would just want this path, whether it's a directory or a file. It'll also accept from standard in, and it'll also send to standard out if you've just got one thing you're extracting. There was some changes to Go UnixFS node to propagate errors better, because UnixFS node hides a bunch of details when it's going over shards. It's doing block loading and stuff in the background. With car extract, I wanted to have an option where you can let it ignore missing pieces of your UnixFS DAG. So you do a car extract, and say it's Wikipedia with one page, and I don't want to have to specify the path. I just want to extract whatever's in there. So now you can do that, and it'll recognize that it's skipping over missing blocks and just extract whatever it can find in there. So Go car extract is becoming pretty useful. And the idea is you can now couple it with Lassie, and you can use Lassie fetch, and you can fetch content, and you can pipe it to Go car, which you can then pipe either to standard out. So you can actually do this now. You can fetch a Wikipedia page with Lassie, pipe it to Go car, and then pipe that to standard out, and you've got your Wikipedia HTML on standard out, which is pretty nice little tool chain. And you can do all sorts of interesting things when you start to build up those those pieces together. So we're so nicely focused on these little pieces. The other thing I'm doing in amongst this is one of the challenges we have with selectors is that because selectors are all about maintaining the correct order of the traversal, it's hard to do selectors in parallel. So which is fine for GraphSync. GraphSync was built around selectors. That's a protocol for synchronizing two peers, their graphs. So they both have an understanding of the graphs they have and the selectors that you want to synchronize. So you can do parallel work in that if you share an understanding with the other side. But when we're doing something like BitSwap, where we're fetching from lots of peers, it's all, you're the one holding all the information, and the peers just hear requests for blocks. So if you're doing a traversal, then it's really hard to parallelize that. When your traversal is being strictly ordered, you're going down this, the left side, and then you go your depth first, all that sort of stuff. So what I've been working on is a way to parallelize BitSwap traversals while still maintaining the ordering. So this is what I'm working on this week. But the trick here, and I'm starting on some work that Hannah started. There's a link in there to a pull request in Go IPLD Prime. The trick is to, when you're doing a traversal and you hit a block, to do a scan first of what are the links that are in that block that I'm going to encounter. So you do the current version, my sort of re-implementation of this based on Hannah's work is to you do a traversal over the block, the single block, and you stop at the block boundary. You collect all the links. You send those links off to an optional preloader, and then you go back and you do the proper traversal. And then in the background, the preloader is receiving, each time it receives a new block, you receive this list of links. And the preloader then has the option to go and in parallel pre-fetch some or all of those blocks so that when they're eventually encountered again, they are already there. There's a bunch of challenges in choosing which blocks to fetch, all that sort of stuff. But what it means with BitSwap is that when we're synchronizing a DAG, we can optimistically fetch blocks in parallel with multiple BitSwap communications. So we can do a traversal and still end up with a nicely ordered car at the end, but with preloaded stuff along the way to speed up the traversal. So yeah, that's the current version I have is working nicely, but it's a bit rough. So that's what I'm up to.
Thanks. That's really cool. I especially like that the tooling finally gets to where it can actually make useful things. So that's super cool.
Yeah, it's nice. It's nice to not have. It's nice to not have to get a kitchen sink application like Kubo to do all this stuff. Like, get Kubo, and then it will do all of the things, but do them all sort of awkwardly. But have these pieces that you can use independently and piece together. It's kind of nice.
Yeah. Cool. Yeah, does anyone else have any updates or want to share something or ask something? Or yeah, now's the time.
Anyone doing any interesting work or made some interesting discoveries or learned something new that they want to share? No. Okay.
Okay. Cool. Yeah, then I guess then it was a quick meeting. Yeah, as every time we have, so we will start the live streaming, then we have the after party in case you have things you don't want to share publicly. And yeah, else we see us again in 2 weeks. And for everyone else, like the daylight saving times around the world start to kick in or did already kick in. So be sure that you join at the right time. This meeting currently is really fixed to a certain UTC time, so it won't change. But yeah, just check your calendar. All right, then see you.